Namaste everyone. So in this video we will solve problem 2.2. So someone asked me to solve this problem. Uh, so I know this is very late response to that comment. I apologize for that. I was a little bit busy. So let's get started. This is the problem. Very easy problem, I would say. I will rate it as very easy problem. So now let's get started. So I am trying some new softwares to make it a very interactive thing. Let's get started. Fine. So we have, let me take a highlighter. Yeah. In this problem 2.2, we have part A and part B. So find the electric field, magnitude and direction, a distance z above the midpoint. Fine. Above the midpoint between two equal charges at equal charges q a distance apart, and figure 2.4 we have given this. Fine. So we have to check that result is consistent with what you would expect when z is very greater than d. Fine. That's fine. Okay. So let us solve this problem, and we will do this problem again when right hand charge, like only this time we have to take in part B, we have to take right hand charge minus q instead of plus q. So let us solve the problem 2.2 part A. So let me take pen. Fine. First of all, it is red. So in this, let me make it bit change in this. Yeah, now it would be fine. So due to this, at point P, we have, like at point P there will be electric field. Fine. And we have two charges, that is q and q, that are separated by a distance d. Okay, so let's say this is a origin, that is O. Okay, and I am assuming the coordinate system in this way. Fine. In this way. Okay, so this is x, y and z. So as it is in 2D, so y z coordinates will be the point of focus for our problem. And due to what should I say, let's say this is A and this is B. So due to charge at point A, there will be electric field at point B. Okay, so direction for that, it will be this. Fine. And what will be the magnitude? So let's say this is E. Fine. Now due to this, like charge at point B, we have electric field at point B, and the direction will be, so how I am deciding this direction? So let me make it clear. So I will join this point B. So that's how I am deciding this direction. And because the magnitude is like q, the magnitude of charge is same on both sides, so so magnitude of electric field will be same. So this will be E. So let me join this P and A. I'm sorry, drawing is a little bit bad. You can tolerate that. I'm sure. So let's say this is theta. This is theta, then it will be theta. Fine. So if I make, so this is theta, then this will also be theta, and this will be theta. So now I will, what I will do, I will take components. Fine. I will take components in what direction? In y direction, in z direction. So first I will take component in y direction. So in y direction. Fine. So when I do components in y direction, So this will be the component and this will be the component. And what will be the magnitude? That will be E cos theta. Sorry, sorry. That will be E sin theta. Okay, that will be E sin theta, and this is E sin theta. Fine. This is E sin theta. Now, what is E here? So let me write the magnitude of E. So E vector. If I write E vector, so just magnitude that will be this, and magnitude of this K, as you know, 1 upon 4 pi epsilon naught. So I will write K Q over R square. Now what is this R? So this is R, and I will, using Pythagoras theorem, you can write it as Z square plus d by 2 to the whole square. So, and this is R, this will also be R. So KQ over R square. What is R square? That is Z square plus d by 2 to the whole square. Fine. I hope till this everything is clear. Okay. So let's move forward. So in bidirection, if you see, let me call it E by. Okay. So E by, then E sin theta y cap. Okay. Minus E sin theta y cap. So it will be what? It will be 0. It will be 0. Now coming to the Z direction. So in Z direction at point P, if I make components, so I will have two components, but they will be in the same direction. So what will be these components? So let me write in Z direction. In Z direction, we will have Ez is equal to, fine, E cos theta Z cap plus E cos theta. Again, same component because theta, they both are equal angles. So E cos theta Z cap. Then this will be twice E cos theta Z cap. Now, what is cos theta? Let me write it here. Cos theta is is equal to, it is based upon hypotenuse. It is based upon hypotenuse. So Z upon under root of Z square plus d by 2 to the whole square. Fine. Till this is fine. So now I will find Ez. So obviously, now see, the effective E will be resultant of both Ey and Ez. But Ey is 0, so effective E will be Ez. That it will be only Ez. So Ez is equal to, because as I writing it as vector, so let me write it as, okay, fine. And so it will be okay. So like it is conceptual thing. If you are writing it as vector, it should be vector. Fine. So Ez vector is equal to twice, and what is E? This is E KQ over under root of Z square plus D square, sorry, d by 2 to the whole square to the power square. It is same. Fine. Why I did square? You will see. Multiplied by cos theta, that is Z over under root of Z square plus d by 2 to the whole square. I think it is fine. It is whole square. Okay. Let me make it bit a little bit less darker. Okay. This is, yeah. Now it is fine. Ez vector. Fine. So it will be twice k q z over Z square plus d by 2 the whole square to the power 3 by 2. I think, I hope this is fine with you. Let me see whether I have space or not. Oh, no problem. I will manage. I will go to the another page. Fine. This one, this one will be the, so what will be the electric field? The electric field will be, the electric field, let me change the color. So the electric field will be E vector will be E y vector plus E z vector. Now E y vector is 0. So it will be simply this one. Fine. Now it is asking, now it is asking whether check that result, like when z is very greater than d. Now you have to find the result. So if z is very greater than d, fine. So you can ignore this part. So Ez, or I should say it is E vector only, because they both are equal. So E vector is equal to twice kqz over z square multiplied by 3 by 2. So it will be z cube, and obviously z cap is going with that, z cap is going with that. So z cube, z cap, and this z will cancel out. So I will let me make it, this eraser is small. So I will write it as directly z square. Fine, z square. Now you got this. Now you see, if you see there, you have to check that your result is consistent with it or not. So I will check consistency here. Let me see. So let me make it here. Fine. So if the z is very greater than d, what does it mean actually? Can you feel it? That there is no significance of separation between them. Fine. So it is simple problem like this. You have charge of q, that means 2q, and you have to find out the electric field at the resistance z. Fine. How will you find out? It will be simply E vector is equal to k. Charge is what? K twice q over z square z k. Now you can see it is same. Can you see? It is same. Okay, fine. Now we will go to the part. Let me arrange a little bit. Like, okay. So to make it in one page, I will do some modification. Fine. I will make it as should I make it an image? No, sorry. Leave it. Fine. As I said, I am just trying it. So where should I fix this? Let me try only this one. Yeah. Can I make it a small? What is this? Sorry. What happened? I don't know what happened. Anyway, I think yeah, it's fine now. So let me put it here. Okay. Now let me put it this here. It is fine. So it is not fine. Now let me do this one only. Sorry. I'm wasting your time a little bit. Sorry. What happened? I'm sorry for that. I'm wasting your time. Okay, so yeah, let me change the page. Fine, just I will copy this and I will just change the page and I will paste it. Okay, fine. Now it is fine. Why I was doing that? Now in part, yeah, I have another solution. I can cut it and I can bring to that new page the previous solution. Okay, fine. What I am doing? Fine. Sorry, I am sorry. I am wasting your time, but this I have to do. Okay, fine. Now in this case, let me see problem. Okay. Repeat part A. Only this time, like we have to change right hand charge minus Q instead of plus Q. So let us forward. So now this is right hand charge. This is minus Q. So let me change the color and make it a bit darker. Okay, this is now minus Q. Now in this case, what will happen? What will happen that this will attract. So the direction of this, so the direction of this will be in this. Okay, and this will be same because nothing changed. Fine. So and this is theta, and if this is theta, this is also theta. This is theta. This is E. This is E. Now if I take component, the same. This is X. This is Y. This is Z. Okay. If I take component, so this in this direction, Z direction, it will be E cos theta, and it will here E cos theta, and here E sin theta, and another one also here E sin theta. Now in Z direction, it will be in Z direction it will be what? So Ez vector will be E cos theta Z cap minus E cos theta Z cap. ये 0 हो जाएगा. So it will be 0. Now in bidirection, if you see that Ey vector is equal to twice of E sin theta, I wrote it directly. You must have understood. So twice E sin theta phi cap. Fine. If you observe part A and if you observe part B, in part A the horizontal component cancelled each other. In part B, the vertical component cancelled each other. So it is nothing. It is a dipole. It will behave like dipole if it is minus Q. Nothing. So E by 2 is E sin theta. And what is sin theta? Sin theta will be, it is perpendicular upon hypotenuse. So it will be dy2 over under root of dy2 over under root of z square plus dy2 to the whole square. To the whole square, yeah. So twice E. What was E? It will be same in magnitude. It will be twice multiplied by kq over z square plus dy2 to the whole square multiplied by sin theta. It is dy2 over under root of z square plus twice dy2 to the whole square. Now what it will be? So ey cap it will be, and 2 will cancel out, so it will be k qd over z square plus d by 2 to the whole square to the power 3 by 2. Let me see if I am making any mistake. Yeah, 2, it is 2, k qd and z square. Yeah, it's fine. It's fine. Now, same, there will be, let me go to previous page. So, yeah, what if it is z greater than d? What if z is very, very greater than d? Next, what if z is very, very greater than d? So what you will do, you will just, if z is greater than d, let me change the color. If z is very, very greater than d, what will be the e? So as you know, this will be equal to e vector because ez vector is equal to 0. So e vector will be k qd over z q. Now simply you must have been thinking that in the previous problem, like in the part A, when z become greater than d, when then we combined, when z become greater than d, let me make it box here. Okay, so when z become greater than d, when we combined q, then it became 2q. If I combine q and minus q, then it will be 0. So it should be 0. But let me tell you that z is very, very greater than d. So z is so large that it will be approximately 0. Fine. When z becomes so large, then it will be, so when you say dipole, you must have seen dipole, you just read about dipole. What if z becomes very, very greater than d? So at one point of time it will be 0. So that's how you can think of it. So this is the solution of this problem. So let me show you it again. Yeah, this is still this. Yes, here it should be. Yeah, okay. So this is part A. Now problem is solved. So thank you. Now we will end our video here.